Welcome to this unit 4. It is in the metrology, measurement and metrology subject. So we are going to develop some devices which are helping us in order to measuring the devices directly, indirectly, and in metrology also to measure the internal, to measure the tolerances also in this subject. So in this way, now I am going to tell you about some important points about this displacement. How you are going to measure this displacement? Can you see the displacement? Means no, we can't see the displacement, ma'am. But here, what is measurement of displacement you want? So displacement is change in the motion of a object. Any object is moving, right? If it is moving, what happens is position changes with respect to x-axis, ma'am. So that has to be measured. How much steps it has taken. So measured using different types of transducers. So there are transducers, ma'am, resistance transducer, capacitive transducer, inductance, capacitance. So many transducers are there. We can measure by using all those devices. It generally converts the mechanical motion into electrical motion. All the motion is recorded into electrical motions and they are displayed on the display in the measurement of this unit, fourth unit. It is called as automation and control systems. So you have to control the systems by automating it. It requires calibration for accuracy also. So calibrate it. So here you can see this is the core part which is going to measure this displacement. Okay. So one primary coil, two secondary coils, they are connected here. So this negative is terminal to connected to this positive. From this we are taking negative, from this we are taking positive. We are controlling the voltage here, V naught. So whatever the readings is there are displayed by this displacement is observed by this core, and this will going to give you in the form of electrical signals we output here, we output here. So one core part is there, one core part is there which is going to read the displacement. See, in the x-axis here I am showing this is the displacement here, which is moving, any object is moving in front of this one. So it will read it, it will give it to this resistors Vs1, Vs2. They will be converting to Vs1 and Vs2 voltages. They are connected to voltage output here. They will be displayed on the screen as usual. They are converted to, definition is to convert mechanical things to electrical things as I shown. So this is the, here I am telling anything it is converted mechanical motion to electrical motion. This is the automation. This is what I am telling about this one. Second question, if I am taking what is the piezoelectric transducer? So this piezoelectric transducer works on piezoelectric effect. So electricity effect also it is going to be used here. It generates voltages when stressed. So stress of a object is known by using this into voltage form. You will convert it to voltage form. In the previous also voltage form only. Used for dynamic measurements, high sensitivity, used in the vibrations and displacements of the sensing elements. So you can see this is a piezoelectric setup here. One base is there. On the base you are having this voltage, output voltage crystal is kept. This crystal is attached to this force members, force summing members. Okay. Now pressure is put upon this line. So this will make some ups and downs which is recorded by this crystal. It is given by voltage output. So pressure is put from this area on this force one, force summing members. These members alter up and down, which is converted to crystal. Crystal is converted to voltage. So the voltage which is stressed is converted here. So because here voltage is used in this piezoelectric method, and the mainly vibrations are displacements. So vibrations and displacements. Any object moving, displacement, vibrations also sometimes generated in the body are recorded. So define this. What is inductive transducers? So inductive transducers also same, dependent on completely inductance. It is based on the change in inductances. So how much of the change in the inductances is there, that will be recorded. So same as usual only. It uses a coil and a magnetic effect. Example is LVDT, linear variable distance transducer, linear variables, means the movement of a linear of object is measured. High accuracy will be there, used for linear displacements, only linear displacements. SIMA, it uses this electromagnetic type transducer, magnets are used. So here you are coiled, this a copper wire is coiled here. So the EMF is here. So the electromotive force is recorded here. So this is a permanent magnet. Okay, ma. Here the motion is moving in front of this magnet. Ma. U-shaped magnet is used. Here ferromagnet core is there in front of this. So any motion here linear, if it is moving, it will absorb and by this ferromagnetic core, and it will be supplied to this magnetic core. So this starts vibrations. These vibrations are recorded in the form of voltage or electromotive forces. So vibrations are made by this magnet. This will shake. The shakes, the displacement of this magnet due to vibrations will be measured here by using this electromagnetic types. So before also, here also some vibrations will be made in the crystal. Those vibrations are recorded. Now what is a capacitive transducer? Here also same, the capacitive transducer, capacitance is used, which works on change in the capacitances. The capacitances is recorded here in the form of voltage EMF. The distance variation changes the capacitances, suitable for small displacements, very, very small displacements we want to measure. High resolution used in the precision instruments. So this is the fixed metal block. One is moving metal. So displacement is happening here, ma. So this will start. This is connected here. This is connected here. This is different diameter. This is different diameter. Now this will moving. This will make some vibrations. These vibrations are recorded in this output area. So the displacement, any displacement object is moving here, then it will make more or less vibrations. So these are the capacitance, ma. Tubes are capacitance. So that is this is capacitance, this is capacitance, but it is a metal block fixed. This is a moving part. Displacement is made here. So it may increase or decrease. That will be recorded by this capacitance. That variations are recorded. That will be very, very small displacements. So capacitance transducer. Next, define what is a resistance transducer. Same, based on the change in the resistance of an object. So it uses potentiometer on the strain gauges. The potentiometer is, it will measure the potentiometer, pressure energy. Simple construction, low cost. It is used for linear and angular measurements. Both linear and angular means angles also measured, linear also measured. So here my resistance 1 is there, resistance 2 is there. Here you are having slider. So full output slider position. This output slider. If any displacement is made, this is recorded by this resistors. These resistors vibrate. So those vibrate this full output slider out zero output slider position. So here 0 and this will go move up. The slider will move up and down from here to here 1, 2, 3, 4, 5, 6. So it will be recorded here in the EMF or voltage forms. The resistors which are recording this are record linear and angular displacements. So which are called as resistive or sliding transducers. Next, sixth question, define what is ionization transducer. What do you mean by ionization transducer? It uses ionization of a gas. Ionization gas is made to flow in this area. So it measures very, very small displacements. So electrical capacitance transducers less than that measures very small displacements. High sensitivity used in scientific applications, requires controlled environment. So here also you can see a filament is there. A filament supply is made. Here filament cathode is there, anode is there. This one side is connected to this vacuum indicator. This other side is connected to grid supply. So grid supply is there. So this is the filament supply. So this is negative and positive, and ionization gas is passed here. This is the enclosure. In this gas is flowing. Due to gas is flowing here, what happens? The negative and positive side you are having some differences that will be recorded, and it will be shown as a reading. So gas is sent from here, ionization gas. So very, very small displacements can be used scientific applications only. Define what is photoelectric transducer. Generally, photoelectric transducer means photons only. See, one semiconductor is there. This is connected here, output one plus and one negative. So now radiations are passed through this. So this is as usually positive side, one is negative side, positive side. When radiations are passing through this, they will make some differences, they will generate here. So that will be recorded as output. So this is a photoelectric transducer. Photo means light only, converts light into electrical signals. So light is converted into electrical signals, uses photodiodes or photocells. Non-contact measurement, you will not contact, just the radiation will come here, it will touch this, and what happens, the readings are recorded. So how much of radiations or light is coming, that will be converted into electrical energy. So they are fast responsive. They are also automated system. So instrument is a automated system. Define what is calibrated procedure. How do you calibrate? Calibrate means measuring or comparing. Compare instruments with standards. Apply known inputs values. Record output readings. Plot calibration curves. Adjust instruments to the reduce errors. So any errors are there, you try to reduce them continuously. See here, one side is there my sensor measurement values. Okay, here you have reference measurement values. Both are these are sensor to be calibrated. These are reference sensor with known high level of accuracy. So zero with constant temperatures. So comparison between these two is done. So as I said, this is a comparison between this. So one is a reference measurement value, one is reference, one is sensor. The sensors are measuring some values from the outside. They are comparing with the standard one, and they are giving you the output. So what is the connection is here? The connection is made here down. Okay, this is the sensor based calibrated procedure. Define what is measurement of stains. So you have to measure stains from ninth question. You can see what is stain is. What is the basic stain gauges are used? Stain is basically a deformation per unit length. So if change in the length is there, change in the length, increase or decrease of the length with original length, it is called as stain. Measured using stain gauges only. Some stain gauges are developed here. So this is circuit. A circuit is four sides resistance. 1, 2, 3, 4 sides. One side you can attach stain gauge. So any changes in this strain gauges will be recorded by these resistors. This is given in the output. So if this is two are there, half bridge, four resistors are there, full bridge. This is a strain gauge. So inside this parallel lines are there. The vibrations in the parallel lines move here, and this is one side cathode, one side anode. They will be recording the vibrations inside this or displacements inside this gauge resistance wires are there inside. This is recorded by this positive terminal, negative terminal. So you are going to get in the electrical form. So they are measured by using strain gauges. This one strain gauge is enough to measure this strain gauges. Important in stress analysis, stress and strain both. Used in the structures and machines, big machines, big structures, big ships, big bridges. Also, how much vehicles are coming, how much stress strain is going. By using these gauges, you can measure. Requires high accuracy, so it will give you perfect values when you are having this strain gauge to be attached on that body of the structures. Define what is types of electrical strain gauges. The strain gauges means this is the basic structure of strain gauge. This is the way how to connect, and this is the halfway and full way I have told you. Remember that total. Anywhere you can use it, strain gauges. So types of strain gauges, we are having so many types. Metallic strain gauges, so which are made up of metals, not breakable, used multiple times. Semiconductor strain gauges, semiconductors you can use. Wire strain gauges, foil strain gauges, based on the application. Whatever requirement, however requirement, you can use it. So here I want to show some of this. This is the strain gauge. This is also a strain gauge. This is a rosette strain gauge. Means here you have connections here, two here, two here. So here four are there. This is a full bridge strain gauges. This is chain. So totally there are number of wires inside chain type of strain gauges. This is shear stress. One side, one inside input is given. Here output is given. So this is a linear strain gauge. Linear movement is recorded. Rosette is used. Shear can be measured. Chain type, full type. So these are the different types of strain gauges which are used for length or variation in the length. What is the define? What is the gauge factor? Same gauge factor is also taken. The ratio of change in the resistance to strain. So I have already told you it doesn't want to change the strain, remains that one only. That is called as you are going to measure. Resistance towards strain indicates sensitivity of the strain gauges. How much strain is there? Higher value means better sensitivity. If more values, then high better sensitivity. Important parameters in measures. Typically around 2 for metallic gauges. So you can read two types of resistance here. See here, ma. This is the force. From here you are giving tensile force. Here also giving tensile force. Definitely this length will increase. This diameter will decrease, ma. Which is called as L plus DL, which is called as D plus DL. So this will be measured in this strain gauges. So it is a change in resistance to the strain. That is what it is telling. Next, after completing 11th question, if I am not wrong, I will take this 12th question. Define what is resistance strain gauges. So resistance strain gauges means resistor type which will resist. So here this is a number of wires here arranged. All the wires has one end positive and other end it is negative end. So here I will get to get the vibrations or the displacements of these wires here recorded. So this is gauge blocking resisting faults. These are the resisting files or wires. This is the gauge blocking means block all the wires are kept inside. It is electrical wires coming. It is solder part here. The strain direction can be positive in the forward direction or negative direction also. Define what is resistance strain gauges. Measures change in the strain resistance due to strain. Used in the Wheatstone bridge circuits. Used in the Wheatstone bridge circuits. It can measure. It can measure tensile strains. It can measure compressive strains. Used in the bending applications. So measures changes in the resistances due to strains. So generally it is a Wheatstone bridge circuit, we can call it as. 13th one, define what is strain measurement for torque. So this strain measurement is also applied on the shafts to measure the torque, means the force of the shaft. Strain gauge is mounted on the shaft. So this is one shaft. You can see 45 degrees angle, 45 degrees angle. It is attached. When the shaft is rotating, the gauges will read the number of tons. It measures shear strength, shear and strain related to torque applied used in the rotating systems. So rotating systems provides accurate torque values. So if you want accurate torque values, it is coming. So this gauges should be attached. This 1, 2, 3, 4. 4 resistors are there. So which are having a galvanometer inside. The end of this one is connected to this resistor. This resistance again is giving here EMF, which is recording here EMF in the displaying. So this is how it is made. So 14th question, define what is strain gauge rosettes. So this is nothing but combination of multiple strain gauges. So multiple strain gauges are measured. Measures strains in different directions. So any direction should be measured. That is rosettes. Types rectangle, delta rosettes. Used for complex stress analysis. Provides complete strain information. So here you are 3 are aligned 45 degrees rosette it is called as. 3 are used at 60 degrees. Here 60 degrees, 60, 60. This is rosette gauge measurements. 3 directions we are coming. Here also 120, 120, 120. 3 directions X, Y, Z you can measure. So the values will not go out of our hand. Anyway, it is measured here. So this is the best rosette you can use. Delta rosette it is called as 120 meters. It provides a multiple strain gauges, different directions also, delta storage. So this is the stone gauge, etc. So here I am ending the unit 4. I have covered the strain rosettes and also I have covered this strain gauge for torque, how we are going to fix on the stage. Briefly explain about a strain gauge means this one. So this is the gear factors, gauge factors, different types of strain gauges, electrical forms I have measured. Also calibration procedure, photoelectric transducer, ionization, decision transducer, capacitive transducer, inductive transducer. What is a piezoelectric transducer? what is the measurement in the difference. So totally maximum I have covered a good number of questions, 12 to 13 for 14, unit 4, which will be helpful for you in your studies. Hope you update your knowledge and keep on correcting yourself for the mechanical field. I hope you have understand all the questions. If any suggestions, please leave